If you are starting out with Go and you are new to the language, can be because Go is your first language, a backend language, or you might be coming from a different ecosystem, something like Python or TypeScript or Java. So as a beginner to the language, to the ecosystem, there are certain things that I personally feel. Now, this is not something that is universal. These are from my personal experiences. There are some things, there are some mental blockers, I would say, which discourages a lot of people to get started with the language quickly and actually produce code that is valuable and that is running on production, and just getting more and more experience through writing more code. These blockers that we are going to talk about, these are the things that I have personally struggled with, and it took me a lot of trial and error to finally understand how to prioritize these things and how to get around these blockers. So I'll get started quickly. This is going to be a short video. I am mostly going to give actionable tips, and if you are a beginner in the Go ecosystem, you can just decide on your own if it makes sense to you. I am pretty sure these tips for people who have been working with Go language, the ecosystem, for a long time, these tips might sound a little controversial, but this is again from my own personal experience, and these are the tips that help me get started quickly and actually write valuable code that runs on production. First thing is OpenAPI, or also known as Swagger docs. Now, if you're a backend engineer, you most probably working with OpenAPI docs, or also known as Swagger docs, in various interfaces. Like we have Swagger UI, we have Scalar, which is a very modern UI which I use, and also Postman supports OpenAPI specs. You can import and start testing your APIs. So OpenAPI is something pretty much all the backend engineers are familiar with and they work with on a day-to-day basis. And if you don't, then you should definitely start looking into it. Okay. Now, my point is, if you are coming, let's say, from a TypeScript ecosystem or a Python ecosystem, for, let's say, frameworks like FastAPI, which has a very good integration with OpenAPI docs or Swagger docs. I have personally worked with FastAPI, and the OpenAPI doc generation, the whole workflow is seamless. And I would give anything to have a framework like that in the Go ecosystem. But again, coming back to the point, if you are coming from these languages like TypeScript and Python, which have very good OpenAPI based tools. In TypeScript, we have TS REST, which is something I use. And we also have TRPC, OpenAPI, and a lot of tools. We have very good integration with Zod and OpenAPI and things like that. So very good support for tooling when it comes to OpenAPI specs. Now, if you're coming from those ecosystems, you are already used to how these code-based OpenAPI spec writing, this just flows through all your workflows. You write it once and it just works everywhere else. You can generate client SDKs from it, and you can do server-side validations from it, and you can generate your documentation from it. It just flows everywhere from a single source of truth. Now you come to the Go ecosystem, and suddenly you are staring at comment-based Swagger docs generation. So Go definitely has code-based Swagger and OpenAPI doc generation workflows. So we have libraries like Fuma docs, etc., etc. But most of the famous ones in the top open source repositories, the famous open source repositories, you can see that most of them still make use of the comment-based workflows. So if we go somewhere here, so this is a open source repository called G-Shark, and as you can see, these are the API endpoints, the handlers, and this is how they are defining the OpenAPI metadata. So this is the security type, this is the summary, and this is the tag. This accepts a JSON based payload, and these are the params. This is the success response, and this is the route, etc. And the first thing that comes to your mind is this cannot be maintainable, right? And it is not. If you have worked in big code bases, which I have, which does this comment based Swagger docs workflows, this is not very fun to work with. These comments can get outdated very quick. This is also prone to things like typos and accidentally removing because of merge conflicts. There are a lot of issues with comment based workflows, and the most important one is it just makes your code looks clumsy. There is a lot of comments in everywhere, and you just don't like to see them. Now, if you're starting with Go, this is obviously going to be a big discouragement. At least it was for me. I distinctly remember 2-3 years back when I was getting started with the language. One of the first things when you're learning a new backend language is you see how the OpenAPI doc generation works, right? Then comment-based doc generation was very famous during that time, 2-3 years back. And this is the one thing that discouraged me to drop learning Go. And I actually did not pick up learning the language for the next few weeks. I was so discouraged because of this one behavior, because of this one practice. So eventually I did work with comment-based Swagger docs generation in multiple code bases, but I personally came up with a solution which works very seamlessly. It is a bit additional work, but if you are willing to do that, then it is just the best. So I'll show an example of my workflow, how I solved this problem of this comment-based Swagger doc generation. This is a sample code base. It's kind of like a boilerplate that I am working on, which is going to be the next series. If you are following my Go-based videos, then after this video, we are jumping straight into building a production level boilerplate, starting from scratch. Of course, I am not just going to throw in a bunch of files and a project structure and ask you to clone the repo and start working. We are going to build the boilerplate from scratch. I'll explain all my intuitions, how I came up with it, why this is my go-to boilerplate for pretty much all my backend projects that are written in Go. So this is kind of a half-written version of that boilerplate. So coming back to the point, the Swagger docs flow. This is what I like to do. Usually, if you have a backend, then most probably you have a frontend. And even if you don't have a frontend, we have this tooling called monorepos. And the famous ones are, I think, NX, which have been there for a long time. And the recent one is the turbo repo, which is something from Vercel, which is very famous in open source repositories these days. So what I like to do, I create a monorepo, and the backend folder has all the Go related code. And I also have a packages folder where I keep all these helpers in the sense tooling helpers that are specifically coming from TypeScript ecosystem. For example, first thing is I have this Zord package, and in this package, what I like to do, we have a package.json for building the package, then starting the dev server, etc., etc. We are not going to go too much deep into this in this video. We are going to explore all of these things. We are in fact going to build it from scratch in the boilerplate video. So I'll just show what the workflow looks like. So in the backend, we have models. In the internal, if we say a model, we have different models. So we have a session model, which reflects the exact state of this table in all the columns in our database. And we also have a token table and user table. So these things are called models. They represent the entity that we have as a table in our database, and that directly maps to a struct in our Go code so that we can work with it for serialization and deserialization, etc. So we have these models, and at the same time, we have this Zord package. And inside this package, we maintain a Zord schema. Now, this is the point that I was mentioning a while back. This is a bit additional work. You have to write your models, your backend models in Go code, and you also have to maintain those same models in your Zod package. Now Zod, if you are not familiar with the TypeScript ecosystem, Zod is initially started with as a validation based package, but it works on top of JSON schema. So it has native integration with a lot of tooling, including the OpenAPI ecosystem. Now, this is the workflow. You have to write your models in Go code, and you have to maintain those same models, the same structure in your Zod schemas, and all those schemas will be maintained inside this Zod package. Now, this bit of additional work is going to reduce a lot of work in the future, which I am going to come back next to, but I'll just show the OpenAPI workflow now. So we also have an OpenAPI package in the same monorepo. And here what we do, we maintain the contracts. So we have this very good library called TS-REST. It is a routing library, but it has very good support for OpenAPI doc-based workflow. This library was mostly meant as a alternative to TRPC, but I noticed that the OpenAPI doc-based workflow works very good with this kind of setup. So I use this library particularly for the OpenAPI doc generation workflows, right? So we have this library called TS-REST. If you want, you can look more into it. But coming back to the important part, we have a contract. So we call this the collection of endpoints a contract, and each contract has different endpoints. And you can give these keys to these endpoints. And now this is our OpenAPI configuration. Compared to our earlier configuration where I showed you the comment-based configuration, which one is very hard to read to, it is very hard to maintain, and it is prone to merge conflict-based issues, etc., etc. This, which is mostly a code-based workflow, where you write your summary, the path of the endpoint, the method it uses, the description, what is the payload it is accepting, and what are the different kinds of responses it can generate, right? It's a very simple and intuitive schema that you can just take a look and you just understand what's happening. Now, this is how we declare all our API endpoints. And at places, what we do, we import the Zod schemas that we had defined in the Zod package. We import that and use it in our OpenAPI TS-REST contracts. So the Zod schemas are already being reused in one place, and it will be reused in other places also. I'll get to that shortly. So once we have these contracts in the index.ts, we import all the contracts and create this one router object. And then what we have this script, which is the generation script. It does some edge case checking and it converts it into a JSON, and it creates two files as OpenAPI.json, one in this folder, as you can see here, and another in the backend folder. So in the backend folder, if you go to static, we have an OpenAPI.json. Now this OpenAPI.json is the latest standard, and all these things that you see from here to here, all these things are generated from only this much code, which are just key value pairs. But because of the close integration of Zod and OpenAPI and TS-REST and all this very good TypeScript tooling, we have our final OpenAPI.json. Now, once that is generated, what we are doing in the Go code, if you go here, we have the system routes and we have a docs endpoint. And if you go inside the handler, we are just reading the OpenAPI.html, which is just the template which serves the OpenAPI.json, and we are using Scalar. It offers a very good modern UI for OpenAPI, and we are just using this CDN script to load it in our HTML, and we are also accessing the OpenAPI.json and we are serving it, and we could get a very good modern UI with this kind of setup. Now, coming back to the final part, if you solely work as a Go backend engineer and you have never worked in the TypeScript ecosystem, this will not make any sense. But the one final advantage, and I think it is a very big advantage of using this kind of setup, we have this final contract there is a very good feature in TS REST. So let's go to TS REST docs. Coming to here, we go to client, we go to now TS REST offers this functionality where once you have a contract like this, where all your API endpoints and all the payloads and all the response types, everything is defined and merged into one single contract. You can take that contract and you can pass it into this function called init client, and you can provide some kind of metadata like what is the base URL of your API and what is the authentication techniques, etc. Once you have that, you have this ready-made client SDK, which is fully type safe for all the inputs, for the payloads, the query parameters, the path parameters, and also the response. You get fully typed response in your front end. So if you're a backend engineer, you only have to maintain an additional Zod package and of course the OpenAPI schema that is for your use. You can generate an OpenAPI docs with that workflow. Additionally, with using the same contract which helped you generate the OpenAPI.json file, that same contract you can use and provide a fully type safe client to your front-end engineers. Or if you work as a full stack engineer, you have a fully type safe client SDK, which you can just call. You don't have to worry about what inputs it take. You will get very good VS Code or whatever editor you use, very good TypeScript support for auto completions. You'll get errors if you try to access fields which are optional and null or don't exist, etc. Like all the benefits of TypeScript you get with just one simple initialization function. And because of all these advantages, this is my favorite workflow. And I encourage everyone, especially people who have this kind of front end and back end kind of workflow. This is a very good workflow which significantly boosts productivity and keeps front end engineers, back end engineers in the same page. You can reduce so much back and forth communication with this kind of setup, because not only all your APIs are already documented, they are also provided in a client SDK in a fully type-safe manner. So because of this, in the boilerplate series that is coming next, we are going to use a similar workflow, and I'll show you how seamless it works and how productive it makes you. So that is point number one. The second one is interfaces. Now this problem I see everywhere and every day. The Go community, if you are active in Twitter or Reddit or Hacker News, etc., or if you follow open source repositories and PR, it will make you feel like you're not writing real Go code or idiomatic Go code, as people like to say, unless every struct has an interface. So if you have a service like user service, or you have a tooling, something called email sender, right? You will find yourself creating interface even though it has a single implementation for this also and for this also, and it will never, in all your upcoming sprints, in all your feature releases, it will never have a second implementation. But you just created an interface just because you're supposed to, just because it is idiomatic Go, right? And that abstraction layer does not really serve any purpose beyond making your code look professional, and just look professional, even though it just makes everything more complicated and harder to read and understand. Now, I'm not saying that interfaces are useless. Interfaces definitely have their place. If you look at the code of standard library, which is open source in the GitHub, if you go through that code, you will see that interfaces are heavily used everywhere, and same for other packages. If you take a look at the code of your favorite packages like Gorm or Echo or Fiverr, or let's say Viper, Cobra, whatever Go package that you most frequently use, if you just open the source code of that package, you will see interfaces everywhere. But that is the point. Unless you are writing library code, you don't need interfaces everywhere. People who create libraries, people who create packages, they have to take into account multiple implementations of a single data structure or a single workflow. For example, if you are creating an authentication library, then you will take an implementation of an interface which has a field called provider and access token and refresh token, etc. These are the generic fields, and does not matter what provider you're using, whether email and password based or in OAuth based, etc., etc. So if you're creating an auth library, you have to create interfaces and you have to let your users provide you implementations of that interface. But if you are working as a backend engineer and you're mostly writing application code, and since in this series we are mostly focusing on backend engineering, especially people who write application code, SaaS applications mostly. If you are writing application code, you can easily get away with passing around concrete implementations of structs. You don't really have to create interfaces unless you have multiple implementations in your application code. So that is something that you have to remember. The pressure to abstract everything, especially in the Go ecosystem related to interfaces, is heavily misguided. Keep interfaces only where they generally serve a purpose. For example, testing, that is a very good use case. Even in application code, let's say you have a repository struct which contains all the other repositories of your backend application. Then if you want to test your services which make use of that repository struct, then you have to create an interface, and for the repositories you have to provide mock repositories using test databases, etc. Like if you have testing workflows like this, then interfaces are a very good use case. But other than that, trying to force the use of interfaces in every single use case of your application code, it's just going to complicate things. It is going to give a lot of wrong impression for people getting newly onboarded to the code base, and it just makes everything less readable. So unless you know what you're really doing, unless you have spent enough time in the ecosystem to realize the actual use cases of interfaces, when to use and what to use, etc., just try to keep the use to minimum and work with structs as much as possible. The third one, this is the most scary one, at least for me, concurrency. So if you are new to the language and you are trying to learn either from the official docs or from any book or from any course, concurrency is something pretty much every resource will try to cover as much as possible, even though the high level primitives like channels, etc., but they will still cover it. And I think the problem with that is it's good to know that these kinds of features, these kinds of primitives, and these kinds of abilities exist in the language that you are working with. And it's good to know that. But someone who's new to the language, the pressure to use concurrency primitives, especially Go, is heavily marketed as a highly concurrent language, which has very beautiful primitives, and it does have very beautiful concurrency primitives. But the point is, since the language is heavily marketed as a highly concurrent language and you're new to the language, you have this pressure that you have to make use of concurrency. Otherwise, what's the point? You might as well write your code in TypeScript or Python. So if you come with this kind of mindset, it is very scary and it is very discouraging to work with the language, at least in the initial days when you are still getting used to the syntax, getting used to the idioms and workflows, etc. So if we take a look at an example, this is an open source repository, and there is this function which makes use of a lot of concurrency primitives. We receive this number of workers, and we receive this weight group and a channel and a slice of channels and atomic value, all these different concurrency primitives that we see in this function, and it is doing something. We don't have to understand what exactly it is doing, but it is ranging through all the values that is coming from the channel, and it is doing some kind of operation here and some kind of operation here. Then it is an infinite for loop, and depending on some conditions, it is breaking out of this loop. Then there is an if condition here, and there is a continue here, and there is another select based channel workflow here. Again, it's trying to receive some value from the channel and some value from the terminating channel, and it is trying to break out of this loop. There is a lot of things happening here. And for someone who is trying to understand the language, trying to create something valuable with the language, trying to create backend applications with the language, this can look very terrifying and can look very overwhelming. And it still looks to me. I have been working with the language for the last 3 years, but if you just throw at me some random function like this, which makes use of a lot of concurrency primitives, it will still take some amount of time for me to make sense of it, to trace through what's happening. So the point here is all this marketing around Go is a highly concurrent language, and you should use the language if you have a lot of use cases around concurrency. This is a little misguided narrative, because at least from a backend engineer perspective, again, if you are a backend engineer and assuming you are mostly going to write SaaS application backend code, then the fact that Go is a highly concurrent language and there is a lot you can do using these concurrency primitives, that is something you don't actively have to worry about, because the standard library, which starts a HTTP web server, if you're creating a backend application, then that's the first thing you do. When you start an HTTP server, every new request that comes and that hits your server is executed in a completely different Go routine. So that is the first thing that you have to remember. So your application, from the first line you start, when you do start the server, from that point on, your application is already a highly concurrent server, because each request is getting served in a completely new Go routine. That is one information that should take a load off your chest, that you have to make use of concurrency. You don't have to make use of it. People who have written the libraries, the people who have written standard libraries, people who have written all these packages that you make use of, they already make use of concurrency primitives heavily to provide you this seamless experience, which almost seems like synchronous, but everything is highly concurrent. So that is one thing. All the libraries, either it is standard library or very famous libraries like Cobra, Viper, if you are using GUI frameworks, then libraries like Bubble, or a lot of packages, your servers like Echo or Fiber, or your ORMs like GORM, XORM, all these different packages that you have to use, or you're going to use most of them. Even if you don't use any of them, you're definitely going to use the standard library, and the standard library already makes use of concurrency primitives a lot. Now the point is, the pressure that you have to use all these concurrency primitives is pretty misguided. You will use packages, you will use libraries which makes use of them, and in your application code, when the situation arises, you have to write code like this. It can be as complicated as this, or it can be a very simple spinning a Go routine with just writing a keyword Go and waiting for it using a channel. So it depends on the use case and how complicated you want it to make. For example, let's say you are writing your application code and you did something here, some code, you executed some operation, and here you are returning the JSON to your client. Now here, after executing, let's say a new user signed up at this point. So the next thing you want to do, you want to send a verification email to that user. So you write whatever your notification logic is. If you have in-app notifications, you write a function, something like send notification, and that function will, of course, will return an error if there are any. So your code might look something like this. And here you have to do if error is not equals to nil, then return nil and error. Otherwise you come here and you return JSON or error is nil. So it looks something like this. So this is your backend code, and a user signed up around here, and you want to send a notification, and which you sent synchronously, and you returned the response. But if you want to enhance it a little more, you can do all this operation inside a Go routine. You can just spin a Go routine just here in the same line, and you can just return instead of waiting for that Go routine. Since your server is a long running server, that Go routine will be executed and the notification will be created. The difference between doing this thing synchronously and doing this thing asynchronously by spinning a different Go routine, performing the operation in a different Go routines, is not much, even though that is still an enhancement. And when these things add up, they can add latency, but when you're starting out, this is not something you should be worrying about. And these are exactly the kind of things that discourages people. That where do I use Go routines? Where do I use channels? Given enough time, given enough experience, given enough use cases in the industry, you will automatically have to learn all these things. But when you're starting out, no need to worry too much about these things. Moving on, the fourth one, which is standard library. If you are starting out with the language, you spend some time in these forums, in these subreddits, and you ask people for advice. What's the best resource? What is the best workflow? And most of the time you will get this advice that no need to use any packages, just use standard library and write everything yourself. Go standard library is extensive enough to support all kinds of use cases. You just have to figure it out. This is a very famous advice in the Go community. In fact, people who use these web frameworks like Echo, Gin, or Fiber, whatever there is, they are a little frowned upon by the community. And I think this is a problem, even though the advice is fair enough and it is true. The Go standard library, especially after the release of 1.22, Go net HTTP package has enough primitives and enough features that you don't have to make use of any other libraries. You can definitely write your backend in pure standard library. But using standard library also introduces a lot of boilerplate. Boilerplate, like you have to write your own middlewares and things like JSON serialization and deserialization, and let's say validation and struct binding. A lot of these things, common workflows, which you will definitely encounter when you're building a backend. And you have to write code for all of this using standard library, which is again possible. People have done that. This repository called Fider, this is an open source repository for feedback management, etc. If you go through this repository, pretty much all the workflows have been done using the standard library. All the JSON parsing, the validation, etc., everything. So if you go to middlewares, you can see all the middlewares, even the CORS middleware, the instrumentation middleware, the localization middleware, everything, the security middlewares, everything has been handwritten using the standard library and the custom Go code. So as I said, this is definitely possible. Again, if you go to the validate package, you can see that they have validation functions for different things, like checking if a particular field is an email or not, if it is a URL or not. These things that is usually used in validation workflows. And same way, if you go to the web package, you have these things called binder. So binding basically means you get a HTTP request. It is a deserialization process. You have to take that JSON string and you have to load native Go data structures. That process is known as binding. So for bind also, they have all this custom code using reflection and binding a route and formatting it. Same way for managing context, they have all these helpers for generating new context, getting the session ID, setting the session ID. So this is what I am talking about. People have done this. There are a lot of open source repositories like this one, Fider, I just showed you. People have definitely done this and they have done it very good. The structure, the code is even better than some of the package-based workflows. But my point is, all this custom code, all this use of standard library to write all this boilerplate code that you are going to reuse throughout your application development, you need a lot of knowledge. You need a lot of experience to understand different workflows. Let's say you are writing a middleware for CORS. Let's say go to the middleware section and we go to CORS. So you need to understand what are the headers to set, how to allow origins, and the idiomatic way in your Go code using a standard library. You have to understand the JSON encoding, decoding, JSON marshalling, unmarshalling, how to properly bind, how to properly validate, and how to write good validation code without affecting your performance. There are hundreds of things that you have to note. Now, again, those things, you might argue with me that those things make you a better Go developer, and I agree with that. They definitely make you a better Go developer. But if you don't have enough time and if you don't have enough motivation, then with all this pressure to write all this boilerplate code, and even if you are not writing it, let's say you are just copying all this code from an open source repository, but you still have to understand that code. Just having a bunch of random files in your code base can get a lot of anxiety if you don't understand them, and they can definitely create a lot of bugs. So again, even if you copy them, you still have to understand that code. And all these things take time, and they take effort, and they take a lot of motivation. So if you are starting new, you might not have that amount of motivation to learn through every single basic, every single foundation, and just learn backend engineering the proper way by doing everything on your own. Or if you are coming from a different ecosystem, let's say you are a backend engineer in Node.js ecosystem or a backend engineer in Python ecosystem, and you want to learn Go, and you are learning on your side in your leisure time, right? You have a full-time job and you are learning in your leisure time. So my point is, you don't have all this time that it takes to understand all these workflows and how to write your own code, because you definitely did not. I can bet that most people in other ecosystems like TypeScript ecosystem, like, or Python ecosystem, which is very famous for backend engineering, it has very famous frameworks like Django and Flask and Fast API, which take care of a lot of abstractions. You only write business logic, everything else is taken care of. So you are coming from those ecosystems, and suddenly you have to handwrite every single logic, starting from receiving the request to binding it, deserializing it, and validating it, and parsing the JSON, creating a JSON, sending a JSON, everything you are handwriting. So you can understand that is pretty discouraging and pretty overwhelming. So my advice is, don't listen to all this pressure of using standard library, using custom code for everything. Later on, once you have gained enough experience in the ecosystem, you can decide on your own that you don't want this abstraction this library is providing, and you want to write your own code. And that is completely fine, and that is in fact great if you are doing that. But if you're starting out, please start with basic libraries which get rid of a lot of boilerplate. For example, you are creating a backend application, you definitely need a kind of server framework. So instead of using standard library and writing all the validation, binding, JSON parsing, middleware code yourself, use a ready-made library, something like Echo or Fiber, whichever syntax that looks good to you. Just start with that. Focus on your business logic, focus on building an app, building a backend that is actually doing something useful, then drill down on your abstractions. Let's say you don't want to use Echo anymore. So then learn how to convert your abstracted backend, which you are using a framework for. Figure out how to do it using standard library. At that point, you have enough experience, enough skill, and enough time to invest this, and you will grow much faster that way. But the number one priority, in my opinion, should be creating something of value first, then drilling down on abstraction. And same goes for other libraries, like let's say a validation library. Instead of writing all the validation code for checking whether a field is number or not, or whether a field is email or not, or phone number, whatever, all these validation, there are like 100 use cases of validation, even though we only use a couple of them, like checking a valid UUID, etc., etc. Instead of writing all this custom code yourself, make use of a famous validation library, something like Go Playground Validator, and save a lot of time. And once you have built something, come back, and if you still want to write your own custom code, then start doing it. Next up is, this is a minor one, even though it is not as dangerous as the other points, so to say, but this still exists. So since dependency injection, so DI basically means dependency injection. So this is a pattern that is pretty heavily used in most of the Go code bases. And To make dependency injection a little more readable and a little more manageable, we have dependency injection frameworks. And one of the famous ones is Wire. You have this build tags that you have to write in this file where you are creating your dependency injection workflow. And then you take all these different dependencies and you just execute this one function called wire.build, and you just pass all the different dependencies in a particular order so that they can be constructed in a generation based workflow. So after this, we get something like this. This is a generated code. They have not written this, but since they have this file, and after running go generation, go gen, you get something like this. It takes all these dependencies and it creates this dependency injection workflow one by one. So it takes this one and it passes whatever the result to this and whatever the result to this, and same thing, we have all these different providers, and this is how we create a dependency injection workflow using Wire. And it does reduce some amount of code. You just pass all the different providers and dependencies in a particular order, and you have this ready-made code generated for you. But my point is, which for someone who is coming new to the language, and even if you have enough experience in Go, if you're not familiar with different practices of how Wire works, what does it mean to be a provider in Wire, and how do you actually structure this, what is the order to pass this, and what is this wire.struct, what is this wire.bind, what is this weird syntax, and all this different, it does come with its own learning curve. It definitely pays in the long run. I'm not sure, I have never used Wire personally, and I don't really see the appeal unless like I'm working on a very big open source repository or a very big enterprise repository. Writing a dependency injection workflow like this on our own, with our own hands, which is not very long, seems more intuitive to me than using a dependency injection framework like Wire and learning all these different keywords and all these workflows is limited to Wire. It is not, this has nothing to do with Go or anything. It's limited to a particular library, and you are spending all this time learning all the primitives of that library, even though you don't really need it. You can handwrite all these things. So this is my intuition for things that make workflows look more complicated. For those things, I would definitely say go with the idiomatic standard library code. Don't try to make use of any packages, because the package adds more complexity as compared to reducing it. And when I say complexity, I mean the readability, the learning curve, etc., etc. So in those cases, definitely just try to get away with the standard library and the typical Go code. Don't use any packages. But in cases where using standard library and custom Go code adds more complexity when it comes to readability, when it comes to learning curve, then go with a package. So it is a simple intuition. Whatever is more simple, more intuitive, go with that and figure it out later. And that's why I suggest, if you're starting with backend, for web servers, go with a existing framework like Fiber, Gin, Echo. And for something like dependency injection, write your own Go code, right? Don't go with a framework, especially when you're starting out. Now, next up, we have, this is the famous one, error handling. You might have already heard this a million times, that error handling is very verbose in Go, and which it is. It is pretty verbose, and as compared to other languages where we have try-catch based error handling, where we throw an error and somewhere upstream the calling function has to catch the error in a way that it has to wrap the function to detect the error and to handle it. If it does not wrap, then that error will bubble up until it terminates your program, until it breaks your program. As compared to that, Go has a very verbose error handling practice. So just checking this string error is not nil, you will get 1,000 instances of this handling. You do something, you get a value and an error, you check if the error is nil or not. If it is not nil, then you do something with it. Most likely you return a generic response, or you return the same error and let the calling function somewhere upstream handle that. This pattern you will see everywhere. And if you find this overwhelming, or if you find this a little discouraging, then I will say just deal with it, because the way I say it, this is like vegetables, and it is good for you. People have written hundreds of articles and made hundreds of videos explaining why it is good. You can watch them, but as I said, just deal with it and know that it's good for you. Eventually, you will get the hang of it, and you will see why it's good for you once you spend enough time with it. But for now, there is no point in explaining why it is good for you. Just work with it. You anyway cannot ignore it. The language will not allow you to ignore it. So work with it and move on. This is something that you just have to get used to. Next up, we have another famous one, which is the project structure. When I started out with the language, I was especially interested in the backend side of it, not the TUI side, not the library side or the command line application, especially the backend side, writing applications and traditional backends. So this was a point of lot of confusion for me, that what is the best project structure. I must have done a research for weeks to figure out what project structure should I use, what project structure is recommended in 2022, 2023, what is the currently trending, currently recommended project structure. And I've seen a lot of people also do the same thing. So the solution to that is just figure out one structure. There is one reference, which is if you search for Go project structure, so you'll get this repository called Go standard Go project layout. Now this is a very good starting point where they recommend this very minimal structure, that you should have a CMD folder where your app lives, which is the entry point of your application. I'm talking about application again, not a library. Libraries have, I think, a little bit different structure because other code is going to import your code, etc. You should have an internal folder where you keep all your logic, which is limited to your application, which is not generic. It is limited to your server, your business logic. Then you have packages. And now here we have, let's say, generic utilities. Let's say you have a HTTP error package, and it is a utility that you can, let's say, just take and use it in any other project without making too much change. And that's how, at least that's how I decide whether something should be in internal or something should be inside package. Same way, let's say you have another package for validation. So you have all this validation related logic here. And if you want, you can just take that logic and paste it in a different project and nothing will change significantly. So in these kinds of use cases, you can make use of this package folder, but mostly most of your business logic is going to live inside internal. Now there are other conventions here. You should create a /API for your OpenAPI specs, for /web for your static assets or templates, configs for your configuration variables, scripts, build, deployments, test, docs, etc. etc. So this is a good starting point, and I think this is pretty much enough to get you started with building a backend application. But even after this, if you're still confused, then I would say just go through some of the open source repositories. As I have here, I have this list of a lot of open source repositories that I regularly take inspiration from, I study and I learn patterns from. And if you still want, you can take a look at the application structure, the project structure of all these different projects, and you try to find the middle ground, whatever works for you, because all these different open source repositories, they are created over the years. Like hundreds and thousands of people have worked on them, and they have gone through multiple migrations and multiple changes, and there is no way to find out that why they went for this particular structure or why they placed a particular file in this folder as compared to a different folder. So there is no way to know all these things without getting first-hand experience. So just skim through different open source repositories, try to find a middle ground, something that is pretty common in most of the applications, and try to implement that. Right? That is something that I did, and it worked pretty great for me. As I was talking about, this is something that we are going to discuss in our upcoming boilerplate series, how to build a perfect production style boilerplate for a Go backend. And this is something that we are going to do in that series. We have a folder here for CMD. We have the name of our app, and we have the main.go file, which starts the server. And we have a static folder, which serves some static assets like logos and our OpenAPI.json, OpenAPI.html file. Then we have templates for email templates that we are generating from the React email package and storing it here. Then we have some utility files here. Then most of our business logic, if you see, that is inside the internal one. This I feel is the most intuitive project structure. There is no way to get it wrong, and there is no way to get into issues like cyclic dependencies. Now, cyclic dependency is something that you will face a lot if you're trying to build your own project structure, especially when you're starting out with Go. You will see issues like you will see compilation errors, like there is a cyclic dependency between these two packages, these two folders. Now, if you go with a very clean, intuitive, flat folder structure like this, then it is very easy to avoid cyclic dependencies. Now, I'll explain how we are going to build this boilerplate, what are the files that are going to be inside them, and how do we structure them, etc., right, in our boilerplate series. But yeah, that's my advice. Find out a middle ground, go with a clean, intuitive structure, keep it flat, and just get started without obsessing over what is the best project structure. And this one is the last one, and this is my favorite, and I know that it is also a favorite topic to discuss for a lot of ORMs. This is one topic which creates a new discussion in platforms like Reddit or Hacker News pretty much every single day, whether you should use ORMs or you should not, and which ORM is the best today, and which ORM is the least amount of issues, etc. Like, there are a lot of discussions around ORMs, and for good reasons. And I think the Go is probably the only ecosystem, only backend ecosystem where, now this is again my personal opinion, there is nothing to debate around it. You should work with ORMs and you should work with raw SQL queries, and you should figure it out on your own, that what works for you. Should not take anyone's word, because these things are pretty subjective. You might like the workflow, so you might not. There are some objective points to them that you can take into account to make your decision, but I still think that the best way to decide is try it out and see what workflow suits you better and what workflow suits your team better. Now, coming back to my opinion, I think Go is the only ecosystem, the only backend ecosystem where using ORMs makes things more complicated, less readable as compared to using raw SQL queries. And I will show what I mean, but this is something I have experienced not after I started with the language. I definitely started with the language using an ORM. So I started, I think I tried out GORM, if that's how, GORM, and also XORM. And I also tried Jet. I tried Bun. Let's see. I think ENT also something I have tried. I have tried Squirrel, and currently the most famous one, which is I think SQLC, right? The code generation based ORM workflow, whatever you might call, even though there also you write SQL queries. So I have learned and tried pretty much all the famous ORMs in the Go backend ecosystem. And what I realized is, again, what I just said, that they add more complexity and they definitely add a lot of learning curve. You have to understand what is the best way to do a particular thing in your ORM. And if you're working in a team, all your team members have to learn that. Since you're already learning a new language, if you are able to reuse all your previous knowledge in a different ecosystem, for example, in this case, you are coming from Python or TypeScript to Go. And you definitely have to work with databases. You're working in a backend, you have to work with databases. So in this case, if you're able to bring your existing knowledge about SQL, since you are a software engineer, I'm assuming that you have enough high level understanding of basic SQL queries. And I think that's pretty much all you need, especially in the AI agent based world that we live these days. Writing SQL queries, writing good SQL queries through agents, through LLM agents, whether you're using Cursor or using ChatGPT, Claude, whatever workflow that you make use of. Writing SQL queries and good SQL queries, performant SQL queries, bug-free SQL queries is pretty easy using LLMs. So the initial pointer about raw SQL queries takes a lot of typing, etc., etc. They don't make any sense, at least in the world that we live now. With LLMs, it's easier than ever. And since you are bringing your existing knowledge of SQLs databases to a new ecosystem, it becomes a little easier for you to get productive faster. You don't have to worry about different terminologies in your ORM and different workflows surrounding it, right? Relationship management, etc., etc. You just write SQL and you just move on. You just get the work done. So that is, I think, the biggest reason to go for raw SQL queries instead of ORMs. Now, the final point is, in other ecosystems like Python and TypeScript, these are the two ecosystems that I have personally worked with. Using ORMs actually makes your code less complicated because of the type system, because of the invention of the community. There is a very big community of TypeScript and Python developers, and years of invention, years of trial and error. Because of that, the current state of ORMs in the Python and TypeScript ecosystem is very good. The complexity is almost non-existent. It feels very natural, and with tight integration with TypeScript, type safety, and editor autocomplete, it just makes sense to make use of ORMs. But when you come to the Go ecosystem, you lose all that. You don't really get a lot of, you do get autocomplete, etc. when you are deserializing into structs, etc. But again, it still feels clumsy because of how ORMs are created and all the reflection and everything that gets used behind the scenes in the Go ecosystem. So I'll just show something. Let's say we search for GORM, since that is the most famous ORMs in the Go ecosystem. Okay, so this is the repository, an open source repository called Track, and a very good repository. I've learned a lot of things from this repository, but they make use of GORM. This is a very famous ORM, GORM. And this is what it looks like. If you want to create a model and also maintain one-to-one mapping with a database table for performing auto migrations and serialization, deserialization, etc., you have to create a model, a struct in Go's terminology, a struct like this. And there you add all the information related to database in these tags. These are called struct tags. They're kind of like comments, but they are taken care of with auto formatting, with Go FMT, etc. So by looking at this, you can see that the ID, this is a primary key, this is not null, and the data type is character data type, and the limit is 36. Right? These are all the database terminologies written in the GORM DSL. Same way, we have other, this is not null, this has a unique constraint on it, this is of type text, it is varchar, right? All this database based knowledge that we have here. Now, some people might like it, some people might not. For one thing, it is easier to just look at a model and understand what is the primary key, what is the constraint on a particular field, etc. So again, as I said, this all comes down to personal preference. I personally don't like it, defining all these database constraints in my code. I like to have a more traditional approach where I write my migrations manually using SQL and I apply them manually using a command, and I like to interact with database manually using raw SQL queries. That is something that I have learned over the time. I also advise people that if you're starting out, I'll say start with raw SQL, because you are skipping one huge learning curve that you have to do with, if you are going with a ORM, you have to learn different workflows, different terminology of your ORM. So since you're starting out, you can save some time by starting with raw SQL, since you already have that knowledge. And even if you don't have the knowledge of raw SQL, you can learn it, and that is something that you can reuse across different domains, right? That is never lost. But learning about a particular ORM is limited to your particular language and particular framework. If I want to show what my workflow looks like, so this is again the sample boilerplate, and this is how I write my migrations. So this is the function I have declared, and this is a table. This is the familiar SQL syntax that all of us have studied in college, worked with over the years. And this is a very normal SQL syntax. I'm using Postgres for this. And you just define the tables, write normal SQL, and you maintain your models. Let's say we have model here, and we have user model, and you have your model here, and you don't have any database based constraint. This is just for the deserialization purpose, since the casing for JSON and the casing for database is a little different. We'll talk about why it is this way in our boilerplate series. But coming back to the point, we maintain a one-on-one mapping of our created table in a Go struct, and we keep it inside a model. And our queries. So if I want to show queries in GORM, so this is model, this is repository. This is what queries, SQL queries in GORM looks like. If you are using an ORM, most of the ORMs will have something like this. You create a model which has a one-on-one mapping to a database table. You pass all the required fields, all the fields you want, and we just call create on it, and it creates it and returns an error if it has any error. Otherwise, it just deserializes the created entry into this particular struct that you created. Same way for update, you take different payloads, and after validating it, you insert them one by one. Then you start a transaction like this, and you execute it something like this. You do something here, and again you do something here, you do something. As I said, there is a learning curve to it. You have to understand what this means, what this means, what this means. On a first look, it is very difficult to understand what is happening, right? You have to spend a little bit of time understanding the terminology and the workflows of your ORM. Now, if I show how queries look in our boilerplate, the way I like to work with in backends. So this is what my workflows look like. Let's say we have a function, a repository function, where we are saying we want to fetch a user using the user ID. So on a first look, if you are familiar with SQL, which you should be if you are working with backend, otherwise there is no point in discussing all this. So if you are already familiar with SQL, you can clearly see that we are doing a basic SQL query where we are fetching from users table, joining with user accounts, again joining with user profiles, and using those values as a field in the returned struct as an account and profile, right? Again, now after we have this query, we just execute it here and we collect it. So I am using this driver called PGX, which is a very famous, very fast driver if you're working with Postgres. And whatever result is returned from this select query is loaded into this particular struct, and we return it here, user, right? For me, again, this looks way more straightforward than something like this. And I know a lot of people prefer using ORMs. For them, it is more intuitive and less error prone as compared to writing SQL strings like this. But again, this is personal preference. Go with whatever you want and whatever your team prefers. But just to give an idea, in our future boilerplate series, in all the projects that we are going to work with, we are not going to use any ORMs. We are going to use raw SQL queries. We are going to use Postgres with PGX, which is a driver. And this is what repositories methods are going to look like, which for me looks way more simple. So with that, I think that's all I have to say. All the blockers, all the discouraging facts, the gatekeeping practices of the community, whatever you want to say, these are the major ones. Of course, there are others, but these are the major ones that I have faced, that I have overcome, since a lot of people who are new to Go are watching this series. And that's why I thought of making this video, to reduce the pressure a little. Go is a very simple language, and if you are familiar with backend concepts, which you can refer to the backend from first principles playlist. If you are familiar with backend and if you have already worked with a backend technology like Node.js or Python, then it is going to be very straightforward. And even if you're new to backend, just knowing the backend concepts is enough to write productive and production style code in Go. You just have to follow the good advice. So that's all for this video. From this point on, I am working on this boilerplate series. We'll get started with that very soon. And after the boilerplate series, we are going to build multiple production style projects, backends like project management software, CRMs, and a lot of other ideas that I have thought of that will build from end to end.